All right, so I'm going to get started. I do want to be cognizant of time here, so I'm going to start my little stopwatch that's going to keep me honest. This is planned to be about a 25-minute talk with 5 minutes for questioning at the end. So let's go ahead and get started. So this is a tutorial session, which means it's supposed to appeal to sort of a broad audience. It's a non-technical talk. But it is sort of laying out a roadmap for NASA's motivations and planning and challenges as we move our archive into the cloud, or portions of our archive into the cloud. Who am I? My name's Katie Baines. I work out of Greenbelt, Maryland at Goddard Space Flight Center. I've been with the program for about 10 years. I started doing metadata work back in 2009, 2010, and am now a systems architect working towards migrating our data to the cloud, as it says on the slide. So actually, before I move on, I'll go back to this starting slide. I want to give you an outline of what I'm going to talk about. So first, I introduced who I am. I'm going to introduce who I represent, what organization I work with. I'm going to talk about why we are looking at doing this migration of our data into the cloud, what we're doing and how we're doing it, the timeline for doing that transition, and then really I'll spend the last part of the talk talking about challenges, risks, and concerns that are often expressed. And then I have a couple backup slides if you get really good questions about how we do our software collaboration and deployments. All right, so just wanted to give you an outline up front of what I'm going to talk about. So first I'll give you our work in context. As I mentioned, I work for ESDIS, which is the Earth Science Data Information Systems. We're an organization that manages the Earth Observing System Data and Information Services, and we're part of the Earth Science Data Systems Program out of NASA headquarters. Here is a non-geospatially accurate representation of our satellites. This is only a portion of the data that we are collecting. We have a number of airborne campaigns, in situ measurements via field campaigns. But just to give you an idea, we have a lot of data, and it's not just our data. We have partnerships with international organizations and other organizations that ensure that the Earth is being observed at all times and that the data is being kept safe. All right, so putting us a little more in context, zooming out from the Earth scale into what our specific organization does. Our sort of the very light blue rectangle in the middle sort of represents our purview within the Earth Science Data Systems. We take data that has been captured and cleaned and done minimal processing to. We do processing, archiving, transformation, and distribution of those data products to support all sorts of activities outside. So we provide free and open access to our data. And we are sort of the library of NASA's Earth Science holdings. So when I say we, and I'll probably say it many times during this talk, I'm specifically talking about our system of science investigator-led processing systems and distributed active archive centers. So SIPs and DACs, I'm sure those acronyms are defined on a later slide. Oops. But we represent approximately 12 data centers that are discipline focused. They cover all sorts of different things, from snow and ice to SAR data to physical oceanography to biogeochemistry. And those centers are distributed across the country from Alaska to Alabama. Just because I'm based in Greenbelt doesn't mean that all of our data is there. Like I said, we have 12 NASA archive centers that are domain expertise, so they have a wealth of user services supporting them, scientists embedded within those data centers to help researchers utilize the data to its fullest potential. We have in our current holdings that are EOSDIS, 8,000 plus distinct data collections and 420 million and growing granules cataloged in our system. So this is sort of getting into the variety and volume as we are looking ahead. So the first slide, when you walked in the room before I began talking, was one of the missions that is really driving a lot of our activities here. And that yellow hockey stick is really a yearly projection of our data holdings growth and the predicted future, driven mainly by two missions, NISAR and SWAT. So they are going to be launching in early 2022, I think, maybe late 2021. I'm not sure if I haven't checked the launch dates in particular, but it's somewhere in that window. And really, it's meteoric growth. Right now, we're getting about 23 terabytes per day across of all of the 8,000 collections. Some are growing, some are static. As we move into this new big data future, that's going to, quintuple to 126 terabytes per day coming into our system. So the blue line here is actually the data that's going out the door. I don't have the most recent numbers for 2020 yet. Or we're actually at the end of 2019, so that's why it's today. I don't have the numbers for distribution in 2019. I would assume it's tracking quite closely and probably over that red line by now. That means that more data is going out the door than is coming in to users. So to give you a high-level systems architecture of how we work, we do have those 12 DACs. There's only 4 on this slide because it's graphical logistics, but they're quite siloed. I mentioned they have user services organizations, data holding. Some are big, some are small. Some have lots of data that is very tiny. Some have a few data products that are extremely large. Those are all driven by these science investigator-led processing systems or science data processing systems. And we maintain out of ESDIS a stable of enterprise services that are represented by that little search or that magnifying glass, that key, that image, and that graph that represents search of our metadata catalog, authentication to users. This is really our attempt. It's not a login per se. It's not an account. It's really our attempt to be able to drive our metrics to say this user is using data from both this data center and this data center. So it is, and then we have imagery that covers the entire archive, or not the entire archive, but over 700 of those products. Visualized. So this is where I plug worldview.earthdata.nasa.gov. Our search catalog is search.earthdata.nasa.gov. So just if you don't have an account or haven't seen us before, please do go and check us out. So this is where we are now. And we have a lot of opportunity to support more interdisciplinary science. If you've gone to any of the Earth Science Informatics, Earth and Space Science Informatics talks, you'll see that a lot of people are looking at interdisciplinary research and are looking to reduce the burden of manipulating and preparing that data for processing. We want to make the data more interactive, more seamlessly interoperable using OGC standards and the like, and we also maybe want to look at streamlining our cost footprint. So we're moving towards this streamlined cloud-based architecture. You'll notice a lot of things in this graph are the same, except there's that big blue box now in the middle that represents our data lake. And don't quiz me on what that means because I'm sure it means something different to everyone. But the intention in this slide is to show that we're putting all the data in together, but the DACs are going to maintain thematic stewardship over their data products that have been assigned to them. We're going to move some of their services from individually accessible to accessible across the overarching data system. We'll talk more about how that's being done in a second. And we're maintaining that expert user support, as I mentioned. All right, so that's sort of the 10,000 foot. And here's the slide of where we want to go. So everything that I'm going to be talking about from here on out has been, I believe, open sourced or is in the process open source. So if you go to github.com/NASA, anything that is tagged EOSDIS, and you can just go over to the right-hand side of that, all of our code has been sort of maintained within NASA and tagged as EOSDIS. So we truly believe in providing open data, meaning free and open to all, open source code to manipulate that data. So this is not only the services, but also the algorithms going forward, and open services that have support for standards like OGC and well-documented and maintained APIs. This is the sweet spot for us. All right, so my job, as I mentioned at the outset of this talk, is to get that data up there. So there's a system called Cumulus. There is, I think, a poster right now down in the poster hall related to the Cumulus system. It is really an open source system, as I mentioned. It's really actively developed, and we have developers working across the country working on it. So each data system has been developing their own ingest and archive systems over the last 20 years. Yay, Tara at 20. As we look forward to migrating to the cloud, this is a real opportunity for us to streamline that process and go to a unified system. Yeah. So this is sort of the big cartoon of the vision. I'm sure you can't see it, but just know that the purple stuff on the left and the golden stuff on the right represent two of our data centers operating independently. Each DAC maintains its own instance of our ingest and archive system and provides customizable workflows to get their data into the system. Just checking my time. All right. So what do I mean by that? If you zoom in on that gold set of boxes, each DAC is maintaining, like I said, their own instances of cumulus, but these product workflows are really just directed acyclic graphs, or DAGs, where the data comes into the system, is processed, metadata is extracted, and it's put into our archive for safekeeping after a series of checks. If data needs to be submitted for browse, or if data needs to be provided for restaging in a different format, this would be part of the workflow system that is implemented by the DAC. And you notice that the boxes in there are differently colored. This is sort of to illustrate that each of the components in each step of the workflow can be independently maintained or maintained by the enterprise. So if you don't need yet another service that crawls an FTP site for data, then you can just use the one that already exists within our domain. Let's see. And each of the DACs that I showed in the previous slide is going to have its own AWS account. So I can tell already that I'm going to have some questions about vendor lock-in, so hold that. We'll get to that. So as I mentioned earlier, the data is just processed in a directed acyclic graph. This is actually a screenshot from an Amazon tool that we're utilizing heavily called step functions. There's a link to it in the lower right-hand corner. It really just shows from cradle to grave how we pick up data, we discover new files on a science data processing system, and put them into our catalog and our archive. And so this is really how the data gets from point A, where it's produced, to point B, where it's stored in object store. So this data is not being manipulated in any way while it's being uploaded. We're not transforming it yet. There are activities that are in place that are looking at staging certain portions of the archive in alternate data formats, but it really does depend on what sort of analysis you want to do. So we don't want to necessarily go out of the gate and say, well, obviously everyone's going to want to do time series, so we should stage it in time series. We're really being deliberate about what the advantages of the various data formats are. So there are a couple people in the audience here that would be able to talk about that, and I'll give them shots out later. So say that whole cumulus thing works out. The data has been delivered into Amazon in S3. Now what? You have a bunch of data in the cloud. How do you get it? Well, of course, as always, we put a link to it in our metadata catalog, so search.earthdata.nasa.gov. But that doesn't really unlock the subsetting or transformation capabilities. And that's been something that has been developed. Each individual DAC, those ones from Alaska to Alabama, all over the country, have their own set of tools for subsetting or mosaicing or reprojecting or transforming data formats. And we want to maintain that expertise. There is a project that we've started working on called Harmony. And here's the elevator pitch for it, and then I'll give a call out to people in the audience for further discussion. A centralized service execution framework where you get logging and metrics and cataloging through a common interface and a search interface. Then you have different things that it can be staging the data for transformation, and then back-ended by common transformation libraries that are maintained at the enterprise level. That'd be the common transformation box on the right, and then DAC unique transformations like, for example, the SWOT water feature averaging that would be maintained by the data center itself. But it would all be back-ended by the same thing. There's a poster this afternoon if you want to learn more about what's going on with the Harmony activity. I encourage you to go check that out, and I'll say, Patrick, you should raise your hand. Talk to that guy. He's the person who is working on the ground about this now and ready to answer your questions. So I've talked about kind of what we're doing. I've talked about who we are. I've talked about why we're doing it. Let's talk a little bit more about when and how we're doing it. So cloud migration, big data. Well, we've already been working in the cloud for quite a while, not at the same sort of level as we're about to be. But we deployed some of our systems to AWS back in 2017 and have been operating them sort of without, you don't have to tell people, in the cloud for the last couple of years. That's the Common Metadata Repository, which is just our API service, and to all that, you know, I mentioned 8,000 collections, but we actually also have CIOS integrated catalog, which balloons our holdings in that tool up to 32,000 collections. So 8,000 of those are ours. The other 24,000 are other data providers. I believe NOAA has a number of holdings. There are holdings from JAXA, ISRO, all sorts of federated data from across the world. And then there's the front end of that. So both of these tools are open sourced. They're running in the cloud. If you hit them now, you'll be hitting an AWS service. In fact, Earth Data Search recently went completely serverless. So that's been exciting. We're continuing to move these data to the cloud, and then once it's moved, start doing refinement on that, how we're using that data going forward. Doing my time check. All right. All right, so what's next? Oh, and then we also have data. We've started moving data into the cloud. So the GHRC, the Global Hydrology Research Center, really focuses on lightning. They actually, as of October 1st of this year, have moved all of their data holdings into AWS Cloud. So if you go and search for GHRC, you'll notice that all of their data has been there. If you want to talk more about how that transition's gone, I will ask you to talk to Will Ellett, who is also in the audience. And can you raise your hand, Will? If you want to learn more about an individual DAX experience, I encourage you to bug him because he's really friendly and helpful. And then the Alaska Satellite Facility based out of Fairbanks has been doing a mirroring of the Copernicus program's Sentinel-1A and B data since in the cloud exclusively since 2018 at some point. So there's several petabytes of data there already and has been being served out for a long time. All right, so that's great. We've been in the cloud. We moved some of our web services. We moved some of our data holdings. What's next? So this is the slide that is really laying out the path for our future data rollouts. So I hope you can see it, but there are 5 DACs right now that are really in the pipeline for starting to move their holdings. This is 5 out of 12, and some of them have already moved. So if you add those 2 in, there's 7 out of 12 DACs that have some sort of path forward to AWS in the next year, or at least some sort of activity. GESDISC is based out of Greenbelt. They're moving the MERA2 model data and the iEmerge level 3 data into the cloud, starting parallel operations starting in July. The parallel operations prep will be starting at the beginning of the summer and lasting through July when we hope to go operational. Similarly, Oak Ridge National Laboratory is one of our data centers is housed there, and they're moving DayMet, and one of their new missions, hopefully Delta X, which is an airborne campaign, will be moving directly to the cloud when it starts collecting data. LPDAC, based out of Sioux Falls, they're also using, they're one of the Modus Land products, so Modus 6.1 and the Aster GDEM are going to be moving into there. These are products that you're probably familiar with. We're also going to be moving a harmonized Landsat product into there, and our very success-oriented schedule now has that happening in March of 2020. Now you probably think, oh, a lot of this data is already in the cloud. So it's a little bit different because when AWS moves your data to the cloud or Google moves your data into Google Earth Engine, that's their data. They've moved it, they've transitioned it from NASA stewardship to Google stewardship or Amazon stewardship. When we put our data into the cloud and start promoting it as NASA data in the cloud, we are the stewards of that data. I just want to clarify, we get all the metrics, we own all the EC2 instances, we pay that S3 bucket bill, we pay the egress bill. That's part of our that's part of being a data steward, and we put our stamp of, yes, we will not make this operational until we are absolutely certain that this is the right data. Collections will be updated as soon as they are available to us. So this is true stewardship in the cloud by NASA itself, so it's taking a little bit longer. In addition, Sentinel-6, which is similar to the JSON missions and housed at our PODAC, or will be housed, mirrored at PODAC, we'll be preparing for that data. I think it's slated to land sometime in 2021. I'm not sure of the date. And then NSIDC is beginning to prototype ISAT2 products, specifically ATL 03 and 08, for rollout to the cloud, probably later in probably the September-October timeframe for putting them into the cloud. So this data, if we follow our schedule, which I hope we do, will all start to be available for forward processing, meaning new data will be born or put into the cloud and mirrored into the cloud starting in July of this year. All right, so that's great. I've painted a great picture of, and I have 5 minutes left to say why this is not going to work. So our challenges and strategies for mitigating this. So vendor lock-in is the #1 question I am always answering, and it's actually one of the easiest things to talk about. There's a lot of different facets to vendor lock-in. The first one is, well, what if you have to move the data? We're actually not there yet because right now the only actual ATO, there's a provisional ATO for Azure, so we're starting to look at that, but the only actual ATO, authorization to operate, that's government speak for you're allowed to put a nasa.gov URL on your data, is AWS. There are activities, talk I saw this morning from NOAA about how you do a data broker to put data into multiple clouds that I think is really promising, and I hope to talk to them about that too. But right now, AWS is the place, and we have to know how much volume we have there. We have to make operational and disaster recovery backups for that data, but we don't have to move it anytime soon. So it's on the horizon of things we have to worry about, future Katie's problem. Application transfer risk. So this is basically saying, well, you're using specific Amazon products. Wait. Yeah. So these are kind of close. Application transfer risk and infrastructure transfer risk. So we're using that step functions thing. You remember that graph with the green circles and arrows? And that is an Amazon product. There are lots of competing products in that space. I think Netflix just released one this past week. It's MetaFlow, something. So look into that, Patrick. But we're always looking at ways to mitigate that stress and mitigate that risk, with open source alternatives that are not locked in. And similarly, ECS, Lambda, they all have open source and cloud alternatives. I know that OpenStack has a whole suite of tools and that allow you to move. So we're not investing dollars in this, but we have it in our mind on how we would do it. Probably running out of time here. All right, so this is the biggest risk. We're actually spending a lot of time and training dollars on training up our developers on AWS. Those certifications, they're not free, they're not cheap, and they are expiring. It's a good business model. This is actually a real risk, I think, as we get our developers more and more integrated into the AWS ecosystem with all the services and tweaks to navigate their interfaces. It becomes more and more difficult. So this is something we have to figure out, I think. All right. Another challenge is end user adoption. So you moved all your data to the cloud. That's great. What now? Are people going to use it in the cloud? Because everybody talks about how great it is to be computing and processing near the data, but not a lot of scientists have trained themselves. So this is where I get to say, some of the DACs are looking at this. They're writing guides on, here's a script for using this data in place. Run it. This is sort of how to create and unwrap an interferogram in the cloud with a Windows machine. This is a great start. This is not a holistic approach. So we are looking at a more holistic approach, a cloud primer or primer. And Justin Rice there, hold up your hand, is leading that effort. This is getting input from all the DACs on how we should be easing users into using the data in the cloud, because really there's a lot of talk on how that's going to be, the savior and Jupyter notebooks and blah, blah, blah. But when you have someone who's like, I have to give my credit card and I can't buy a server, that's a different conversation to have. All right, so another challenge. So we've talked about vendor lock-in. We've talked about end user adoption. Cost control is a big problem for us, and I could geek out all day long about this because this is really a problem. As a government employee, there's absolutely no way that anyone's going to be allowed to spend any more dollars than Congress has allotted them. So Cost controls is something that we keep a very close eye on. Moving the data out of the cloud is not free. Storing the data in the cloud is not free. Processing the data in the cloud is not free. However, we do have budget and cost monitoring. And so if you've done your cost model, if you're a data center or a DAC who says, you know, I'm going to store 500 gigabytes of data and then this year and 750 gigabytes next year, and I'm going to use this much compute to do that, we actually can predict your costs out. This is not real numbers, but this is just showing you that we can allocate at our level the amount of dollars that are being spent. This could also be extracted and used in like grant proposals that include cloud credits. This gives us a really nice insight into how data account holders are using their dollars. And you can enforce, so there's that enforcement element on the tab. You can say, you know what, you've overspent. It's time to turn off the fire hose. So we're heavily investing on that because it's really our duty as your government to, or as the government, to properly spend taxpayer dollars. Another thing that we're doing is cost-conscious development. So these are not real numbers, but they actually are really close to real numbers. This is where our money is going. When we are spending dollars at AWS, and this is 76% of it is just storage, and only 10% of it is compute. And all those other things are not things that we need to be optimized. So optimize where you're going to make the biggest impact. So when we look at how we can intelligently store and tier storage, this is the kind of things that we're looking at. Because if you save, 50% on your Elasticsearch services by doing something clever, you've not saved a lot. All right. Another thing, and this is probably the longest, and I'm over my time now, is security. So all government agencies are sort of beholden to the Department of Homeland Security, and that's a good thing. We are here to be kept safe. We want to make sure that all of our data is unassailable and trustworthy. So in addition to enforcing and adhering to NIST standards, we also have made security more of a holistic thing within our organization. We have code security group working groups, which allows developers to find out if they've, what can prevent them from leaking a key, or what can prevent them from using a library that has dependencies that have malicious code embedded in them. So we continue to have these discussions, not just at the management level, but also with our users on the ground and our developers. And that's really important. We're always evolving and looking for new tools to utilize in that regard. Also, being that we are a government organization that is operating in the cloud, we can't give you an account and say you're allowed to do whatever you want. There are limitations on the management and access control, and we try to document for each service, these are the things you're allowed to do, this is why they're limited, and these are the rules within a VPC or without a VPC. This is how you create a firewall rule. So we try to keep really good documentation on what is allowed and not allowed, because Amazon will allow you to spend as much money and make dumb decisions. They'll warn you, but they will allow you to create unsecure environments that are prone to malicious intent and actors. All right. So this is sort of my talk. I'm an engineer. I'm really focused on how to move the data and how to make sure it's a sustainable activity, repeatable, trustworthy, available, all those things. This doesn't really touch on big data per se, because we will be able to handle that data. What is done with that data is really the purview of people with different job titles than me. So we have been looking a lot at moving the data, putting all the data in the lake, that there's many opportunities on what are the proper formats to put the data in. What do you do if you want to stage a certain amount of data for a certain amount of time? How do you expire that data? How do you share that data? How do you put algorithms into the cloud and allow people to put their own algorithms in the cloud? This is where we want to be going. So hopefully next year we'll have a talk that is about how we've evolved, how we moved all this data, and now what's next. And now I'm done. So any questions? Oh, well, yeah, I'm done. Questions? Well, thank you. Have a good lunch. Hopefully the lines are not too long. And thank you so much for coming.